Hi guys, today we start to study chapter 1, the scientific method. It contains 12 sections divided into 4 parts. We will learn how scientists study the nature or the universe. We will learn about the solar system, about the universal gravitation, and about the International Unit System. Section 1, the scientific method. What is the scientific method? It can be simply defined as a pattern of steps to study the universe or nature. How many steps does it have? 4 steps. Formulating problem, experiment and observation, interpretation, and testing. First, you formulate a particular problem that you want to study. Then you do some experiments and observation to have information or collect more data on this problem. Third, you make an interpretation to this problem. Then at last you test the interpretation. This schematic shows the flowchart for the scientific method. If the interpretation does not pass the testing, then you need to go back to the second step. Do more experiment and observation. Make a new interpretation and test again. Iteratively repeating this process until the testing gets a positive result. At this point, you may have successfully developed a new theory or a law. It depends on how big the problem is. What is the law of physics? A physical law tells what the relationships or regularities between occurring phenomena are. For instance, the Newtonian gravitational law. It is a law that tells the gravitational force between two bodies. A theory explains why the phenomena occur. For example, the Einsteinian general relativity, a theory to describe the effect of matter on spacetime. A hypothesis is an initial scientific interpretation, not tested yet. For instance, the dark energy that is needed to explain the acceleration of the universe. The dark energy is not tested yet. It's just a hypothesis. A model is a simple version of reality. For example, oval is a model of Earth's orbit. The real Earth's orbit is actually a non-closed ellipse, not exactly an oval. Section 2. Why science is successful? First, what is the science? Science can be simply defined as a living body of knowledge, not a frozen idea. There are 2 types of science: life science and physical science. The life science is a science for living things, while the physical science is a science for non-living things. This course is about the physical science. Physical science can also have many types, such as computer science, that's a science about the computer, space science, that's a science about the space, and so on. Why science is successful? There are many reasons. Here we list only three. First, science is correct. It predicts correct results. If science is incorrect, then it is no useful. Second, science can help us to understand the nature. For instance, space science helps us to understand the weather. And science can help us to develop technology, for example, computer, car, airplane, and so on. Section 3, a survey of the sky. When we watch the sky, we can see a star in the northern sky that seems barely to move at all views from the Earth. Years after years and centuries after centuries, it appears at the same place in the sky. This star is called the Northern Star. It is also called Polaris because it is located above the North Pole of the Earth and aligned on the Earth's axis of rotation. It was usually used as a guide for Thales. Nowadays, we are guided by GPS. There are many groups of stars near the Polaris called constellations. Some typical examples of constellations are Little Dipper, Bigger Dipper, Big Dipper, Little Dipper, and Cepheus, and so on. The map of constellations can be used as a clock of season. When the area connecting the head of the big dipper to the Polaris point upward, it is January. It is July when this area points downward. The most significant celestial bodies in the solar system to us are the Sun, the Moon, and the planets. The Sun is the star closest to us, called our star. The Moon is the only satellite of our Earth. That's the nature satellite. Planets are big celestial bodies orbiting around the Sun. There are 8 planets. From the inner orbit to the outer orbit, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. About 2 decades ago, Pluto was counted as the ninth planet. Now it is categorized as a dwarfed planet. All planets move across the sky daily, but drift slightly eastward related to the constellations. About the solar system, there are 2 fundamental models. The first one is called Ptolemaic system. It is a geocentric system that describes the Earth at the center of the universe, and the Sun, Moon, and all planets revolve around the Earth. This system was developed in the 2nd century, but discarded after the 16th century because this system failed to accurately predict planetary position. Another model of the solar system is the Copernican system. It is a heliocentric system that describes the Sun as the center of the universe, and the Earth rotates on its axis once a day. This system can accurately predict planetary position and accepted since the 16th century. It should be noted that it is too strong to say the Earth is the center of the universe. We should just say the Sun is the center of the solar system. According to the modern cosmology, the universe does not have a physical center. Section 6 is about Kepler's three laws that quantitatively describe how planets actually revolve around the Sun. The Kepler first law says that the path of planets are all ellipses with the Sun located at one focus. This is the focus. This is ellipse. Two focus here. The second law, the Kepler second law, states that a planet moves so that its radius connecting the Sun and the planets sweeps equal area in equal time. The A means area, the T means time. This implies that a planet moves faster if closer to the Sun. Slower if further from the Sun. The Kepler third law describes that the ratio between the square of the time needed for the planet to make one revolution and the cube of the average distance to the Sun is a constant, independent of planets. Using T to represent the time or period, and R to represent the average distance to the Sun, we can write the Kepler third law as this formula: T squared over R cubed equal constant C. Now we do an example to apply this law to solve some questions. For example, let's do an example using the Kepler third law. The first question of this example is to determine the constant C from the period and the average distance of the Earth. Then, given Jupiter's period equal to 12 years, find the average distance of Jupiter from the Sun. So that's the two questions about this example. First, since the Earth's period is 1 year, and Earth's average distance to the Sun is 1 AU, then from the Kepler third law, we can obtain the constants equal the square of the Earth's period and over the cube of the average distance of the Earth to the Sun equal 1 square over 1 cube equal 1. The unit is year square over AU cube. So the constant equal 1 in this unit. Here AU